Cominciamo. Okay, good morning at all. I think we can start. Welcome to this talk about observability and observability in Drupal. So how we can understand how Drupal, what our Drupal is doing by observing it from the external. I'm Luca from Italy. I'm a Drupal developer mainly, and I work for Fabric. That is a Drupal and cloud native agency in Italy. And I contribute some modules to the community, like Web Profiler, Monolog, and so on, and some of my social accounts. Fabric is a is a tech company in Italy. We have engineers, developers. We do design. We do a lot of Drupal and a lot of cloud native applications. So we need to understand what our Drupal is doing on the cloud. And we are partner of some of the mainly public cloud providers in the world. Okay, so right now in this era, basically everyone is working with distributed systems because we have microservices, containers, cloud, serverless, and a lot of combinations of those technologies. And this increased the number of failures we may encounter because there are a lot of systems interacting. And usually in those distributed systems, it's difficult to understand where the failure occurs and why. So we have to observe the system to understand and to prevent problems. Observability is a measure of how well internal states of a system can be inferred just by looking at the external outputs, so without looking into the system. And when we need to observe production environments, we need more metrics other than CPU and memory and so on. We need to collect and analyze a lot of more metrics about the application. So we can use these three pillars of observability that are structured logs, metrics, and traces, or distributed traces if we are implementing a distributed system. So in this talk, we are look at all those 3 points to understand what we can do in Drupal. For instrumenting our application, we will use this technology. It's called OpenTelemetry. It's quite new, about 1 year ago. The OpenCensus from Google and OpenTracing from Uber merged together to create this new OpenTelemetry stack that is a collection of tools, APIs, SDK that it can be used to instrument, generate, and collect telemetry data. It is an incubated project from the Cloud Native Computing Foundation, and it aims to provide the infrastructure to collect metrics in a vendor agnostic way, so you can then use the format that you want. And it has been adopted by all the main cloud vendor, public cloud vendor like AWS, Google Cloud, and Azure. So you can use those cloud vendor to collect and analyze metrics. Okay, OpenTelemetry, as I said, is quite new. For the PHP, the support is not so good at the moment. we are in the pre-alpha status for tracing and metrics. Logging is not yet implemented. But for example, for Go application, the tracing stack is stable, and also for JavaScript, for example. So OpenTelemetry is interesting. It's not quite ready to be used in production. In this talk, we will use some other technologies to do all the observability we need. We will use Monolog to collect logs, Prometheus to collect metrics, and OpenTelemetry to collect traces. And then to storage and visualize all the data we collected, we will use Grafana. And in the next examples, we will use Grafana Cloud. That is a hosted service you can use, but everything is the same if you have a Grafana installed on your cluster. Okay, just a couple information about the tools we are using. Monolog, first of all, is a standard PHP library. It's used in every PHP project, probably. It can be included in Drupal using a contrib module. And Monolog is useful because it can send logs to files, sockets, inboxes, databases, wherever you want, and implements the PSR3 interface. That is the same interface that Drupal logger uses internally. So it can be easily integrated. Then we will use Prometheus. Prometheus is an open source system to do monitoring and alerting. It was built by SoundCloud, but right now it's open source and maintained independently. We will use Prometheus to collect and store metrics. And also Prometheus is the second project that joined the Cloud Native Computing Foundation just after Kubernetes. Okay, as I mentioned, we will use Grafana to store and display metrics, and the architecture will be this one. So suppose we have 3 applications. Okay, we instrument all of those applications to send logs, metrics, and traces to a Grafana agent. That is a Go software that you can install, for example, in the same cluster as your application. And then the Grafana agent will send logs, traces, and metrics to 3 components of the Grafana stack. That is Loki for logs, Tempo for traces, and Prometheus itself for metrics. And then we will use the Grafana user interface to do queries, extract information, and visualize them. Okay, let's start with structured logs. So logs are about storing specific events when they occur, basically. As we know, in Drupal 8, we can use Monolog. That is a PHP library that is used a lot, so it's quite stable and robust. Monolog is a library from Jordi Boggiano, that is the same developer behind Composer. And there's a module for that, of course. So we can install a module in Drupal. The Monolog module is also available for Drupal 10 if you want to try it. So you can just download the Monolog using Composer to have both the module and the Composer library, the PHP library. Right now we have the version 2. And then you have to configure it. Monolog doesn't have a UI to configure it. You have to configure Monolog using YAML file. For example, you can create this site's default Monolog services.yaml file in your file system, and then in that file, you have to define, first of all, a service. In this case, we call the service monolog.handler.rotating_file because we want to route our logs to the file system, just rotating it every day. So we must need to tell Monolog the path of the log file, how many files we want to maintain. Okay, after the 10th file, it will delete the first one, and so on. And the level of logging we want to store, we want to start from. So in this case, we will log in the debug.log file everything from info upwards to fatal. Then we using parameters in the same YAML file, we will define handlers, formatter, and processors that are used to configure Monolog. So in this case, we are creating a channel for the default messages. So we are collecting every log messages from Drupal. We will say that the handler is the rotating file service we have defined. We want to route logs in a JSON format, and we want to apply a set of processors that basically alter the log message before it will be brought in to the file. And in this case, we are using this message placeholder, for example, to replace the message from the Drupal log to the log string itself. We want to log the current user, the request URI, the IP. Maybe we want to filter backtrace to limit the length of the log message. In the introspection process, insert in the log message also the file name, the line in the file where we log that specific message. And at the end, we need to register this YAML file in the service container of Drupal, so it will be available to the system. And when we log something, using the standard Drupal logger service, we will obtain this information in the log file as YAML. We will as JSON. Sorry, we are using JSON and not a simple line string because it's easier to parse and then to extract the information. For example, we can query our log to specific logs. And here we have the message, the level, every information from Drupal, and then a lot of information from the processor that alter the logs. Okay. So structured log, it makes it simple to query them for useful information, and you can easily route a Monolog processor to add information to your log. So if you need to log, for example, information from the cluster or some other information you need to query, you can route a processor. Okay. The problem using logs is that we have multiple servers or multiple pods. We collect logs in multiple places. Okay, so maybe if we have different web servers and we are storing logs as file in the local file system, we had a lot of those files that we have to discover, scrape, and collect together. So we are using another component of the Grafana stack that it's called Prometheus. That is an agent. It's included in the Grafana agent component that we install and used to scrape, discover, scrape, and collect and send basically logs to Grafana Loki, that is the component in the Grafana cloud that receive and store logs. So in our infrastructure, we have this prompt tail deployed within the Grafana agent on every machine, maybe of the that has application that we need to monitor. Okay, for example, this is the a simple configuration for Loki. Basically, we just to tell Loki and prompt tail where our logs are, where to send them, and some other information about labeling or so. And at the end, on the Grafana cloud or in the Grafana instance on the web application, we will see all the logs for every sources we collected from with all the information in JSON, and in the Grafana UI you can query for whatever information you need. So the path is we use Monolog to collect log to file system. We use prompt tail to send to Loki and visualize with Grafana. Okay. The second pillars we will talk about is metrics. And metrics are a measurement of a point in time for the system. So we measure a value that that our system have in a specific time. For example, we can monitor the number of time we receive an HTTP request, how much memory or how much time the request handling consume, how many requests currently in progress, number of errors, and so on. So specific values in specific point of time. For doing so, we are using Prometheus, but we are in this talk we are using the SDK provided to OpenTelemetry to interact with Prometheus itself. The architecture is this, so we have a lot of applications or components in our stack, so we can use Prometheus to instrument not only the PHP application, but also the web server, the database, the machine itself. We collect all those metrics, we store them on a local instance of Prometheus, and then we forward them to Grafana Cloud to be stored and visualized. Okay, the Prometheus instance that runs locally is itself in the Grafana agent, so you don't need to install Prometheus on your machine, because into the Grafana agent there is Prometheus. Okay. We wrote a module to integrate Drupal with OpenTelemetry to expose at the moment traces and metrics. We call this module Observability Suite. Is a very early stage, but you can download it and try it. And in the next of the presentation, we will see how it works. Okay. First of all, Prometheus by default scrapes data about your website, contacting an endpoint that is /metrics. If you reach this metrics, you will see a text response with all the metrics that are collected. But in PHP, we don't have a storage. We don't have an application server that runs like Java, for example. So we need a way to store the data we collected between one scrapes and and the next one. And the observability module for Drupal at the moment uses Redis as a storage backend to store all the collected information. So in your stack, you have to install also a Redis instance to collect to store all those information. And then the module automatically instrument some basic Drupal information. At the moment, we collected the number of requests per route, time of request per route, and PHP memory used, maybe also per route. So we collect those information every time a user reach your website. And if you go to the /metrics endpoint of Drupal with the observability module installed, you will see all those information that is in a Prometheus format. That is a basically standard format to export metrics information. And for example, here we see the PHP version that is automatically provided by the Prometheus exporter. Then that we hit the entity.user.canonical route one time, the memory and the time that Drupal consume to render that that URL in this bucket format. This means that we have one request that takes more than 0.5 megabytes, I suppose, for the memory. And so it's one request that is more than 0. So it's one request that is more than 0.7, 0.1, and so on. And the same for the time. So it store in a bucket all those information, in buckets all those information. Okay, the same as for logs, we can configure the Grafana agent to scrape, call the metrics endpoint, scrapes data and send the data to Grafana Cloud. And in this case, we need to insert the targets, so the host name of the web server where Drupal is running. In this case, this is an example using ddev locally. So every 1 minute, it download from ddev Drupal 10 web /metrics all the metrics and send them to Grafana Cloud at this endpoint. Okay, and this is all done automatically. So you just install Drupal, install the module, configure the Grafana agent, and on Grafana you will see all the metrics collected automatically about time, memory, and request. You can also manually instrument your custom code if you want to understand what your custom code is doing. In this example, we just count how many entities, generic entities, has been created in your Drupal instance. So we are implementing this hook entity insert, then retrieve this observability metrics matter service from the service container, and then increment the metric that it's called entity_insert, for example. So this is the name of the metric. It's just a label you can define. Then you can provide a description of the metric, and then some labels. Okay, and in this case, if we go back, in this example, you will see here it's a little bit smaller, but here Prometheus is routing the description you insert in the code, and between parentheses for every bucket and for every information, you have, for example, the path, because the path is the label of the automatically instrumented code. In our case, we are using type and bundle for labels. So in this example, we will have bundle node, bundle article type node, for example, for every entity we are creating. Okay. Prometheus is also useful because you can collect, instrument and collect information about all your system. So, for example, you can use this component from Prometheus that it's called node exporter, okay, to export information about hardware and the operating system, for example, like CPU, memory, file system, and so on. And this is useful because then you can see your system from the internal Drupal standpoint and from the external. And maybe if you have some CPU spike or some memory spike, maybe you can understand why in that moment you have those spikes, because you can analyze both the system and both the application in the same dashboard. Okay. So putting all together, you can create a dashboard on Grafana with logs and, for example, memory of your application per path, and also trace it, but we are talking about tracing later. And for metrics, the path is you are using the observability tools, observability suite modules in Drupal to store data to local Redis, send them to Prometheus, and then use this remote write to send them to Grafana. Okay. The observability suite module for Drupal 10 is just, at the moment, is a proof of concept. We are working on it, but you cannot use it in production, probably because it does not collect a lot of information. There is a more robust module to do that it's called Prometheus IO Exporter on Drupal.org, and this module is also developed by Spark Fabric. And then you can install that module and also implement custom plugins if you need to expose more information. So take a look at it. Okay, traces. So we are talking about logs, metrics. Traces are information that is scoped to a request. So we need to understand all the path with our request from the browser back again to the browser itself. Okay, we are using the observability suite module to instrument our application to provide tracing. And internally, the observability suite module is using OpenTelemetry to do all the work. Okay, and this is needed because maybe we are not just using Drupal anymore, but from Drupal we are calling external services, external microservices to complete the information you need on a page, for example, and we need to understand all the journey between Drupal and external services and back. For example, if we have a Drupal 10 in this case, a Drupal website that renders a page with some data inside that comes from a remote web service, we want to trace all the calls between Drupal, the remote web service, and back to understand exactly the path. Okay. For example, this is a controller, standard controller in Drupal. We are injecting into the controller the HTTP client, the standard HTTP client service provided by core, and then we use the client to call a remote service, take the response, and render the message in the page. This is quite standard. What we want to, okay, this is the web service. If you want to check the code, it's just probably 5-line Go application that takes the request, respond a message, and collect the information. Then we want to send all the traces we collect during this page render and send them to this component of the Grafana stack that it's called Grafana Tempo. That is a traces storage. And in this case, it's quite easy. We just need that we are using the HTTP protocol to send to OpenTelemetry, and then the endpoint of the Grafana cloud where the traces are sent. And what we have on Grafana, this is just an extraction of all the trace. We see that at some point Drupal calls the controller, then it calls it performs an HTTP call to an external microservice, for example, and then into the microservice, so into the Go code, we have just a sleep of 1 second that simulates some work, and then when the microservice return, Drupal go ahead and build and render the page. So with this kind of information is useful to understand where the time is spent. So for example, our controller is taking 1 second and 0.1 to complete, and this is because internally he called an external microservice that took 1 second to complete, and so on. In this case, we just use the module that sends information to Tempo, and we are using Grafana to visualize. Okay. As for the metrics, the observability suite modules in Drupal already instrument the application to collect some traces. And we at the moment we are collecting events, Twig templates. So every time Drupal call on events, or anytime Drupal use Twig templates to render something, every time Drupal performs an HTTP calls to an external system, and if you want, every time Drupal invoke a service. But this is optional because usually in a single page request, Drupal will call hundreds of services, so it's slow. So if you enable the service instrumentation, your page is not usable anymore. As you see, for metrics, we can also trace our code. For example, this is the same controller from the example before. Suppose that after you receive the information from the remote microservice, you do something with the data. Okay, for example, you do some complex calculation. For example, in this case, we sleep 1 second just to simulate this. The observability module expose a service that it's called tracer, and then you can use this method to build a span every line here trace terminology, every line is a span that has a start and an end, basically. So you create a span, start it, then do all the complex work, and close the span, basically. So it records when the span starts and when the span ends. And in the same Grafana dashboard, you see that you have the HTTP call, then the call to the microservice, the return to the microservice, and then your 1 second span that represents the work you have done. So in this case, it's not in this slide, but in this case, the controller took probably 2 seconds, because 1 second to call the microservice, 1 second to do the internal work. You can also set attributes to the traces. That can be useful when you look at the trace on Grafana. That can be whatever you want, and in the Grafana UI, you will see every attributes you collect. On Grafana Cloud, they are called tags, but it's the same information. Okay. One last thing we can do is correlate traces with logs, and basically logs with trace. So every time you log something on Drupal, it is useful to understand that log from where request response come out. And to do this, because it's quite easy to provide a processor to Monolog to add to log information whatever you want. The observability module introduces a new processor for Monolog that adds a trace ID to every log, and then you can add this tracer to the list of processors in the Monolog configuration file. And on the Grafana Cloud, for every log, you have a button to go to the trace. For every trace, you go a button to go to the log for that trace. So you can correlate all the information. And that's it. Okay. So of course, thanks to the sponsor for this conference. Everyone, stay in touch, and more important, of course we did a lot of help to complete the implementation for the Observability Suite modules. So if you want to contribute to the module and to the OpenTelemetry itself, because it is in pre-alpha status, so they need a lot of support to complete the implementation for PHP. So if you are interested in those topics, I'm here until Friday. So if you want to understand internally how this is implemented, feel free to ask when you want. And then, if you have some question, okay.
Hello. What's the impact on performance? Because we all know that New Relic APM or Blackfire has impact. When we observe something, we have an impact on it. So is there a big overhead? What about it? What's the impact?
Okay. I don't have specific data about the overhead, but of course, when you instrument something, a small amount of time is spent in the instrumentation itself. So all those systems, OpenTelemetry itself supports the concept of not collect information about every request, but you can monitor maybe using a parameter in the URL or something like that, or maybe collect information from one request every 1,000 or 100. At the moment, all those is not implemented in the module, but of course we have to do that before it will be in production ready. Otherwise, it will slow down the website.
Okay, thanks.
Well, I have the same question for all speakers actually. Why are you doing this? What is the outcome? So I mean, you see how it here it consumes that much memory, it takes so much time. But do you have an example that your application had like response time of 2 seconds, and you made it like reply in 2 milliseconds or something like what? The practical outcome.
Yes, basically one of the main information you have is where the time is spent. So when you know where the time is spent in the request response lifecycle, you can maybe optimize. So for example, if your page took 2 seconds to render, but 1.5 seconds is from an external service, probably you can do anything on your website, so you can concentrate on the external service, maybe. And this is the same for tracing and for metrics, because trace points out where the time is spent, and metrics usually is useful to correlate the time spent in your application, the time memory of whatever metrics you have spent in the application, with the time memory of what you want spent in the rest of the infrastructure. So you have spike in memory, for example, in the database or in the web server. Maybe you can understand why those spikes are in the infrastructure from inspecting the code of the application. I don't know if yes.
I just wanted to know how would you compare this, maybe as a complement or a substitute or a competitor to XHProf? How do you see them? Is it the same scenario use case that you see, or?
Okay, XHProf is to instrument PHP itself. So you see all the calls between PHP functions in the code, and it's maybe complementary, because maybe you cannot use XHProf in production, because it also adds some overhead to the code. So yes, you can use both. Maybe each XHProf more on localhost to understand all the path, or you can use Blackfire to do the same on specific requests on production, to understand the path into the code where maybe time and memory is spent. So yes, you can use both. Any other question?
Okay. How those tracing work with regards to using a CDN, load balancer, and all that? Is it like transparent? Will it work like transparently? I mean, you didn't talk about it, so I'm wondering how does it work to do tracing end to end. You know, you were talking about tracing inside Drupal, but how does it work like in the the
course.
big picture to put the Drupal trace inside the bigger trace, you know?
Okay, so of course you can trace from the load balancer to the infrastructure. The point is using those tracing technologies like OpenTelemetry, the first time you start the first span, it generates a trace ID. Then that trace ID is propagated through all the components of the stack, so it can correlate everything, and it uses normally it uses HTTP headers to set the trace ID, and then every component reads that trace ID from the request, add some spans, and then propagate. In effect, we instrument the Drupal HTTP client to inject the trace ID into the HTTP header, and in the the example in the Go application, we extract that trace ID and create spans child of that trace ID. If you create that at the beginning of the request in the load balancer, you can trace everything.
Okay, and so is it part of the OpenTelemetry standard? Like the header is like a standard one?
Yes.
Okay.
The specification of OpenTelemetry define the name of the header, the value of the header. Then you have the implementation. So maybe in the cloud provider you're using must have the specific implementation of the OpenTelemetry specification, but if you have it, you can trace everything.
Okay. Thanks.
AWS is the one that is doing a lot of work integrating OpenTelemetry in all the stack, for example.
Thanks.
Oh, you're welcome. Any other question? Okay, so I think we are done. Thank you again. Enjoy the conference.